In 2009, during the Hungarian Grand Prix, a 1.7-pound steel spring fell off Rubens Barrichello's car. Moments later, Felipe Massa, traveling at 175 miles per hour, struck that spring head-on. It hit his helmet with the force of a bullet. In any other era of racing, this would have been a fatal blow. But Massa walked away. How? The answer lies in a piece of equipment that costs more than a luxury sedan and takes weeks of handcrafted precision to build. Today, on Process Sector, we're going behind the visor to see how $10,000 Formula One helmets are engineered to survive 300 km/h crashes. The evolution of the lid. Before we dive into the factory, we have to understand what these helmets are fighting against. In the 1950s, drivers wore leather caps and goggles. It wasn't until 1954 that Bell introduced the first purpose-built racing helmet. Fast forward to today, and the FIA 8860-2018A BP standard is the most stringent safety regulation on the planet. ABP stands for Advanced Ballistic Protection. This standard was created specifically because of Massa's accident. It requires a reinforced strip of Zylon, a material stronger than Kevlar, to be integrated into the shell. These helmets aren't just hats. They are carbon fiber survival cells for your brain. Materials. Beyond carbon fiber. Where does the world's most expensive safety gear begin? It starts with the suppliers. While standard motorcycle helmets typically use fiberglass or basic polycarbonate, F1 manufacturers such as Bell Racing, Stilo, and Schuberth source aerospace-grade materials. The primary ingredient is prepreg carbon fiber. Unlike standard carbon fiber, prepreg comes pre-impregnated with a precise amount of epoxy resin and must be stored in massive industrial freezers at -21 degrees Celsius to prevent premature curing. But the real secret weapon is Zylon. Zylon is a synthetic polymer that is 10 times stronger than steel. A single 1 mm thread of Zylon can hold the weight of a grand piano. In an F1 helmet, Zylon layers are placed specifically across the forehead area to stop high-speed projectiles from piercing the shell. The step-by-step factory process. The 3D scan every F1 helmet begins not in a mold but with a laser. Manufacturers use portable 3D scanners to map the exact dimensions of a driver's head, down to the millimeter. This ensures that the internal pressure is distributed perfectly across the skull. There are no small, medium, or large sizes in F1. There is only Lewis Hamilton size or Max Verstappen size. The hand-layered shell. The process sector is most visible in the clean room. This is where highly skilled technicians, often with backgrounds in aerospace, begin the layup process. They use metal templates to cut over 15 to 20 individual pieces of carbon fiber, Zylon, and Kevlar. Each piece is placed by hand into a female mold. The orientation of the weave is critical. Technicians must overlap the sheets in specific directions to ensure the shell can absorb energy from all angles. One mistake in the layering could create a weak spot that fails during an impact. This hand-layering process alone can take over 6 hours per helmet. The autoclave and the bake. Once the layers are set, the mold is vacuum sealed in a plastic bag to remove all air bubbles. It then enters the autoclave, a high-pressure industrial oven. Here, the helmet is cooked at 135 degrees Celsius under high atmospheric pressure. This force compresses the layers together into a single, ultra-light, ultra-stiff structure. When it emerges, the shell is so strong you could drive a tank over it without it deforming. Drilling and trimming. After the bake, the shell undergoes robotic trimming. A 5-axis CNC machine or a high-pressure water jet cuts the eye port for the visor and drills holes for the ventilation ducts and the radio cooling system. Even these holes are a feat of engineering. They are designed to pull hot air away from the driver's face using the Venturi effect, all while maintaining the aerodynamic profile required at 200 miles per hour. The interior, comfort meets chemistry. The EPS and Nomex inside that rigid shell sits the most important part. The expanded polystyrene, EPS liner. This isn't the stuff from your coffee cup. This is multi-density foam designed to collapse at a controlled rate during a crash, slowing down the brain's deceleration. The foam is then covered in Nomex. This fire-retardant fabric is the same material used in driver suits. It can withstand temperatures of up to 790 degrees Celsius. If a car catches fire, the helmet provides the driver with about 30 to 45 seconds of breathable air and heat protection. Critical seconds needed for the marshals to arrive. The visor. A ballistic shield. Finally, we have the visor. F1 visors are made of a special polycarbonate that is 3 millimeters thick. But look closely at an F1 helmet, and you'll see the top 10 millimeters of the visor is reinforced with a Zylon strip. Why? Because the gap between the visor and the shell is the most vulnerable point. During testing, an air rifle fires a 1.2-gram lead pellet at the visor at 500 kilometers per hour. If the pellet even cracks the inner surface, the design is rejected. The final assembly and the art of paint. The finishing touches, the last stage of the process, happens in the paint booth. You might think paint is just for looks, but in F1, weight is everything. A standard paint job can add 100 grams to a helmet, which feels like 500 grams under high G-forces. Specialists like Jens Munzer Designs use ultra-thin layers of paint and stickers to keep the weight under the 1.4 kilogram limit. Once the paint is cured, the final hardware is added. The hands clips, anchors that tether the helmet to the driver's shoulders. The radio system, noise-canceling microphones to talk over the 120 decibel engine. The hydration tube, allowing the driver to drink during a 2-hour race. From the frozen carbon fiber sheets to the hand-painted gold leaf, an F1 helmet is a masterpiece of modern manufacturing. It is a $10,000 insurance policy that a driver hopes they never have to truly use. So, if you had $10,000 to spend on your car, would you buy a custom helmet or a set of performance tires? Let us know in the comments. And if you want to see how other high-performance machines are made, make sure to subscribe to Process Sector. We'll see you at the next factory.